Okay, complex numbers. So, a complex number, this is where we're talking about imaginary numbers, or you've probably heard imaginary numbers. So that's the imaginary unit I, named because imaginary starts with an I. And it's defined as the square root of -1. So I is the square root of -1. We can't square root negative numbers. There's nothing that you can square to get a negative number. That's where we get into these complex numbers. Okay? And complex numbers are actually used in real mathematics. Okay, I know they're used in some engineering programs. I know they're used in like astrophysics, I'm pretty sure, and different sciences. So like imaginary, we call them imaginary, but that's not necessarily their best name. Complex is a lot better because there is actual applications for these, okay? And then a pure imaginary number, or a complex number as we'll call it, is written in the form of a plus bi, where a is the real number and b is the imaginary part. Okay, so they're complex. So let's break these down. So if we have the square root of -144, well, that's the same thing as the square root of -1 times the 144. I know that the square root of -1 is I. So we can break this up into two separate square roots. And we learned this back when we were doing the square root properties, or the radical properties, that you can break it up. So we're working backwards now. But the square root of -1 is I, and the square root of 144 is 12. So that's going to be 12i. Cool? Let's do this one. So -80. So again, we're going to break it up as -1 times 80. So that's going to be I square roots of 80. And then let's break down that 80. So 80 is 2 times 2 times 2 times 2 times 5. You can make a factor tree of that if you don't believe me. And then we have two groups of 2. So that's going to be 4i square roots of 5. This one, square root of -36 over 121. Well, I can pull out the I because of the negative, so that's I square roots of 36 over 121. Now, just like multiplication, how you can split it up, we can do the same with division. You can split that up. So that's square root of 36 over square root of 121. Square root of 36 is 6. Square root of 121 is 11. So that's 6i over 11. Okay? Now let's look at powers of I, because there's a pattern to this. There's always patterns in math. So I know that I to the first power is just I, right? Now, we know that I equals the square root of -1. That's really important. We need to remember that. Let's figure out what I squared is. So let's just square both sides. Well, I squared is the square root of -1 squared. When you square a square root, it just goes away. So that means that I squared is -1. That's kind of cool. What about I cubed? So I know that I cubed is the same as I squared times I. I know that I squared is -1, so that's going to be -1 times I, which is -I. Okay, now what about I to the 4th? Well, that's I squared times I squared. I squared times I squared, that's -1 times -1, which is +1. Cool? Let's do I to the 5th. Well, I know I to the 5th is I to the 4th times I. I know that I to the 4th is 1, so that's 1 times I, which is I. I to the 6th, that's I to the 4th times I squared. I to the 4th is 1. I squared is -1, so 1 times -1, that's -1. I to the 7th, I know that's I to the 4th times I cubed. I know that I cubed is -I. And if we didn't know that, because you might forget, you know that I to the 7th is I to the 4th times I squared times I. And we know that I to the 4th is 1. I squared is -1, and I is I. So that would be 1 times -1 times I, which would be 1 times -I, which is -I. And then I to the 8th is I to the 4th times I to the 4th, which is 1 times 1, which is 1. Okay, so if you divide by 4 and it goes in evenly, the exponent by 4, it's going to be 1. Okay, if you have a remainder of 3, it's -I. If you have a remainder of 2, it's -1. And if you have a remainder of 1, it's just I. Okay? So notice this patterning here, which is kind of what I just talked about. This continues forever. Okay, there's so many patterns in math, and the more I've delved, I don't know the word, into math, the more I've realized like how beautiful these patterns are and how beautiful mathematics is, because it's the one universal language. And anyways, but yeah, so this pattern continues forever. So let's look at I to the 11th. So I know I to the 11th, that's I to the 4th times I to the 4th times I cubed. And I want to break them into the fourths as much as I can. So that's 1 times negative I, which is negative I. Now 6i to the 13th times 18i cubed. Well, 6 times 18, that's 108. I to the 13th times I cubed is I to the 16th. Well, I to the 16th can be broken into I to the 4th, I to the 4th, I to the 4th, I to the 4th, which that's all 1, so that's really just 108. Okay, this one. So remember, when you have a power raised to a power, you multiply, but it also has to distribute to both of those. So that's 2 to the 5th times I to the 45th. Well, that's going to be 32. I to the 44th, because I know that 4 goes into 44, so that can be broke up into 4s. So that's just going to equal 1 times I, which equals 32i. Okay, this one. I know that the square root of negative 9 is 3i, so I want to do that first. And then I can do my exponent part, so that's going to be 3 cubed times I cubed times 2 to the 6th times I to the 6th. Well, that's 27 times I cubed times 64 times I to the 6th, which is 1,728, I to the 9th, which is I to the 9th, or I to the 8th times I, which would be 1,728i. Cool. Feel free to do those ones. H is a really big number. Like, your calculator won't even give you the numbers. So, just so you know. Let's look at this one. So, adding and subtracting complex. Think of it the same way as when you were doing, I don't want it to be red. When you were doing like x plus 3 plus x minus 4. Okay, we just combine like terms, right? So that'd be 2x minus 1. We're going to do the same thing here. So we're just going to combine like terms. So 6 minus 8, that's negative 2. Negative 4i plus 6i is 2i. Cool. Let's do this one. Remember, subtraction, you distribute that subtraction sign first. So you would go here and here. So that becomes the negative 4 minus 6i. And then combine like terms. So that would be negative 7 minus I. This one, multiply, distribute first. So we're going to multiply and you get 18 plus 12i minus 5i plus 7i squared. Combine like terms and you get 18 plus 7i plus 7i squared. Well, I know that I squared is negative 1. So I'm just going to put that in for there. So that becomes a minus 7. And then 18 minus 7 is 11. Okay? So 11 plus 7i. This one, we're multiplying. I'm going to use the box here. So we have 5 plus 3i, 9 minus 8i. 5 times 9 is 45. 3i times 9 is 27i. 5 times negative 8i is negative 40i. And 3i times negative 8i is 24i squared. Okay, and I know that 24i squared, if you plug in negative 1 right there, that'd be negative 24 times negative 1, which is positive 24. So then 45 plus 24 is 69, and then 27i minus 40i is negative 13i. Okay, we're going to skip those next three. Please try to do those. And L, because I also skipped L. Okay, let's look at this. So we've rationalized denominators with square roots and with radicals, and now we're just doing it with i's. So it's the same exact concept, but instead of multiplying by a radical, we're going to multiply by an I, or the conjugate of a complex number. So here we just have an I on the bottom, so I'm going to multiply by I over I. On top you get 6i, on bottom you get 7i squared. Well, I squared is negative 1, so that's really negative 7. You don't ever want a negative in the bottom, so just move it. If it's a monomial, you can just move it in front. So that'd be negative 6i over 7. This one, so 26 plus 4i divided by 8i. we're going to multiply by I over I. So that's going to be 26I plus 4I squared over 8I squared. Now we have two I squareds here, so I'm just going to substitute in -1. So that's going to be 26I minus 4I divided by -8. And then I want to reduce this, so 2 goes into all of those. So we're going to divide each of these by 2. Okay, 26 divided by 2 is 13. 4 divided by 2 is 2. -8 divided by 2 is -4. Again, we don't want a negative in the bottom, so we change the signs in the numerator. Or, that's the same thing as multiplying top and bottom by -1. So the top would become -13i plus 2, the bottom would become 4. And that's the same exact fraction, it is equivalent. This needs to be in the form of a plus bi, so it's actually going to be 2 minus 13i over 4. This a plus bi is very important. Okay, all complex numbers are written in that form, so you have to remember that. All right, this is one where we have to do the conjugate. Remember, conjugate, you just switch that middle sign. So we're going to multiply by 2 plus 6i and 2 plus 6i. So that's going to be 2i plus 6i squared, and then 2 minus 6i, 2 plus 6i. Well, if we use the box to multiply this, we can see that 2 times 2 is 4. Negative 6i times 2 is negative 12i. 2 times 6i is 12i. And then 6i times 6i, negative 6i times 6i is negative 36i squared. But that I squared is -1, so that's 36. Negative 36 times -1, which is positive 36. Sorry, words are struggling. And now, what happens to these i's right here? Those cancel out, right? And you're just left with 4 plus 36. A hint to multiplying conjugates, you always take the first number and you square it. So you're going to have 2 squared. And it's always plus the second number squared, so 6 squared. Which would have been 4 plus 36, which is 40. Okay, that's just a hint. If you don't want to do that and you want to do it the long way because you need that, that's completely fine. Do it the long way, okay? And so then we're left with 2i minus 6 over 40. 2 goes into all of that, so that's I minus 3 over 20. It needs to be in the form of a plus bi, so that's going to be -3 plus I over 20. Cool? I want you to try you. And then operations with negative radicals. Okay, on these, you always have to simplify first. So I'm going to pull out the i's here. So that's going to be I squared roots of 15 times I squared roots of 5. The 15 can't break down, the 5 can't break down. So then we're going to multiply outsides with outsides, insides with insides. So that's going to be I squared square roots of 75. I squared is -1, so that's negative square root of 75, which 75 can be broken down to 5 times 5 times 3. So that's going to be -5 square roots of 3. Okay, you have to pull the i's out first. I would write that down. So pull i's out first, not literally. I mean like i's, like these i's, not these i's. Don't do that. Okay. How do I get that out of there? Pull i's out first. Okay. Let's look at this one. 2 square roots of -10, -3 square roots of -2. Pull out the i's. So 2i square roots of 10 minus 3i square roots of 2. Well, that's going to be -6i squared square roots of 20. I squared is -1, so -6 times -1 is 6. Break down that 20, and it's 2 times 2 times 5. So that ends up being 12 square roots of 5. Okay, this one, pull out i's first. So that's going to be I squared roots of 2 times 5i squared roots of 6 plus, and then break down, I broke down this 18, because 18 is 3 times 6, which is 3 times 2. So that's where that came from. And then we can distribute in here. My belly is growling, I'm hungry. So I squared roots of 2 times 5i squared roots of 6, that's going to be 5i squared, square roots of 12. And then I squared roots of 2 times 3 square roots of 2 is 3i squared roots of 4. Then we break this down and simplify it. So I squared is -1, so that's going to be -5. That's where this came from. Break down the 12, that's there. And then 3i, the square root of 4 is 2. Okay, here we have a group of 2, so I can pull that out. So that's -10 square root of 3, and then plus 6i. This one, I'm going to use the box, but I'm going to first pull out my i's. So 3 minus I squared to 3, -8 plus 2i squared to 3. Then I can use the box here. So 3 minus I squared to 3, -8, 2i squared to 3, so that's going to be -24, 8i squared to 3, 6i squared to 3, and -2i squared to 9, which is going to be -2 times -3 squared to 9 is 3, which is 6. So that ends up being -18 plus 14i square roots of 3. Okay, I want you to try and do Y and AA, and remember to take the quiz. You're awesome. Bye.